Ever pondered about the destiny of our universe? The cosmos, a sprawling expanse of enigma and awe, has captured human curiosity since time immemorial. As we peer into the limitless depths of space, we are compelled to question its future. The fate of galaxies, stars, planets, and even us is not just a philosophical conjecture, but a scientific conundrum that researchers worldwide are determined to decipher. Their curiosity has birthed numerous theories, each as captivating as the other. From the ominous Big Freeze to a devastating Big Rip, these theories traverse a variety of prospects, some unnerving. Some among them also includes the idea of a cyclical universe in the Cyclic Model, and the endless realities speculated in the multiverse theory. Today, we venture into the profound details of these 10 theories, each providing an insight into the potential destiny of our universe. The journey promises to be an adventure beyond the known, into the world of cosmic wonders and possibilities. So sit tight, prepare for an exciting exploration traversing the realm of the unknown. Dive with us into the cosmic world as we unravel these theories. Imagine a universe growing infinitely cold over time. This, my dear listeners, is the grim forecast of the Big Freeze theory, a riveting hypothesis that plunges us headfirst into the icy depths of the cosmos. This theorization posits that as the universe continues its ceaseless expansion, the ambient heat will slowly dissipate, leading to a gradual decrease in temperature across cosmic expanse. Now you're wondering, how does this come about? Our universe is akin to a grand cosmic theater, an astronomical spectacle with galaxies, stars, planets, and myriad celestial bodies all playing their respective parts. However, as the stage broadens, these celestial performers are gradually distancing themselves from each other. This constant expansion results in less interaction, leading to less energy exchange, which in turn brings about a gradual cooling down of the universe. Stars, the universe's luminous powerhouses, won't escape this ominous fate. Over eons, they'll exhaust their nuclear fuel, their once brilliant light slowly dimming till they eventually fade into oblivion. The universe will then be bereft of stars, leaving darkness to hold sway. When the last star flickers out, the universe will be confronted with a near absolute zero temperature scenario, a state so frigid that even atoms would cease their motion. The Big Freeze theory paints a disconcerting image of a universe that transitions from a thriving, bustling cosmic metropolis to an eerily silent, frozen wasteland drained of all its energy. The concept of such a vast, energetic and dynamic universe being reduced to a frozen, lifeless void is truly a chilling thought, a chilling prospect, isn't it? What if everything we know was to collapse into a single point? A tantalizing query, wouldn't you agree? It's the driving concept behind a compelling astronomical theory, the Big Crunch theory. This compelling theory invites us to envision a unique universe, a realm where gravity supersedes the force of expansion. A cosmos where the vast galaxies, the myriad stars, and the infinitesimal atoms cease their constant outward movement. Here's a thought for you to ponder. These celestial entities would not just stop moving away from one another. They would reverse their course, accelerating their pace towards a singular point. Imagine a cosmic collision of such an enormous magnitude that it would confine every particle of matter and every iota of energy into a space tinier than a pinhead. But the story doesn't stop here. There's a twist. Some scientists, those who delve into the mysteries of the cosmos, propose that this immense crunch could trigger another Big Bang, a cosmic explosion birthing a fresh universe. Picture a phoenix, a mythical bird rising from the ashes. In our scenario, though, it's a universe being born from the remains of its predecessor. With this theory, we stumble upon a provocative possibility. The universe as we know it neither be the first of its kind nor the last. It puts forth the exciting idea of a cosmic cycle, universes birthing and dying, only to be reborn again. Fascinating, isn't it? A cosmic reset button, perhaps? Or could the universe tear itself apart? Picture this unsettling scenario, the cosmos in all its grandeur, stretching and stretching until suddenly it breaks. This is the foundation of the Big Rip hypothesis. This theory doesn't just propose an expanding universe, it actually suggests accelerating expansion. The force driving this acceleration isn't yet fully understood, but we commonly refer to it as dark energy. What is dark energy, you may ask? The truth is, even scientists can't provide a straightforward answer. Dark energy is an enigmatic, yet powerful force that exists in our universe and is believed to be the culprit behind its accelerated expansion. As per the Big Rip theory, If this dark energy continues to increase in strength, it could potentially outweigh the gravitational that hold everything together: galaxies, stars, planets, even atoms. This foreboding prospect paints a picture of a universe where galaxies drift away from each other, stars and planets are stripped away, and eventually every particle of matter disintegrates into isolated fragments. A universe where even the fundamental particles of matter are not spared from the relentless expansion of the cosmos itself. Although this theory might sound like a plot derived straight from a science fiction novel, it's a possibility that scientists are seriously considering. With the universe continuously expanding at an accelerated rate, the Big Rip theory is a plausible explanation of what could occur billions of years from now. Truly, an ending that is as dramatic and cataclysmic as it sounds. Could our universe be just one in a cycle of births and deaths? This profound question leads us directly to the concept of the Big Bounce theory, a fascinating and somewhat controversial theory that has captivated the minds of cosmologists for decades. Let's delve deep into what this theory proposes. Imagine, if you will, a universe that isn't stagnant or steady, but rather one that is constantly in motion, expanding and contracting, like a cosmic yo-yo whirling in the vast expanse of space. This is not a singular event, but rather a continuous, cyclical process, an infinite loop of creation and destruction, of birth and death. This, the very heart of the Big Bounce theory, a theory that boldly suggests that our seemingly unique universe could potentially be just one of countless ones that have existed before us, each one emerging from the ashes of its predecessor like a phoenix reborn. But how does this process occur? How does universe give birth to another? The answer, according to the proponents of the Big Bounce theory, is intrinsically intertwined with the concept of the Big Crunch, a theory we touched upon earlier. According to the Big Crunch theory, our universe, given enough time, could ultimately collapse under the weight of its own immense gravity. It paints a grim picture of the end of everything we know. However, the Big Bounce theory offers a different perspective. It posits that this catastrophic collapse is not the end, but rather the beginning of something new. Following the Big Crunch, a new Big Bang would inevitably occur, thus heralding the birth of a new universe, forever oscillating between expansion and contraction. This remarkable model of an oscillating universe sees the cosmos not as a static entity, but as a dynamic, ever-evolving continuum, continuously renewing itself for all of eternity. Within this model, each so-called death of the universe is not a cataclysmic event, but merely a prelude to a new beginning, the universe forever caught in a cycle of rebirth. What if the universe could destroy itself in an instant? This thought might send shivers down your spine, but it's the premise of a fascinating theoretical concept known as vacuum decay. Now you might be wondering, what exactly is this phenomenon? Well, imagine the universe not as a tranquil, perpetually expanding space, but as a ticking time bomb primed to self-destruct. This idea posits that our universe might exist in a false vacuum state. Think of it as a semi-stable phase. This brings us to an integral aspect of this theory, the Higgs field. The Higgs field is a crucial component in physics, a field of energy that permeates the entire universe. Picture it as an invisible energy field present everywhere in the universe. It is impossible to see with the naked eye, but its effects are profound. Should this Higgs field drop to a lower energy state, it could theoretically trigger a vacuum decay. This decay could cause the formation of a bubble of true vacuum. Now, what would this bubble do, you ask? This bubble, once formed, would then expand at the speed of light, annihilating everything that lies in its path. This destruction would be so sudden and swift we wouldn't even see it coming. We'd be obliterated before we had any idea of the danger. Now, before you start feeling terrified, let me reassure you. The probability of such a vacuum decay occurring is infinitesimally small. It's more of an interesting thought experiment than a looming threat. But the theory of vacuum decay serves as a reminder of the intricate and unpredictable nature of our universe. It paints a picture of a universe that's not merely a peaceful, ever-expanding entity, but a potential ticking time bomb, ready to self-destruct, a universe-wide apocalypse triggered in a flash. Could the universe simply fade away? This question introduces us to a harrowing idea known as the heat death theory, an assumption that our universe might reach an inescapable conclusion. Let's delve into the details of this fascinating yet distressing concept. Heat death, also referred to as the Big Chill, is deeply intertwined with the second law of thermodynamics. This law dictates that disorder, also known as entropy, consistently increases over an extended period. Picture the universe as an enormous cosmic apparatus ceaselessly working, with stars continually evolving, ceasing and detonating in magnificent supernovae. However, with every cosmic occurrence, a tiny fraction of usable energy dissipates, morphing into heat that scatters across the vastness of space. As the passage of time stretches into billions and billions of years, this process incrementally results in a state of heightened entropy. In this state, the universe, having exhausted all its energy reserves, transforms into a homogenized mixture of particles, all at a consistently uniform temperature. As a result, there are no more stars, no more galaxies, only an extensive, frigid emptiness. This is the representation of the heat death scenario, a portrayal of a universe that hasn't been annihilated but has merely expended all its energy. At this point, the universe is not destroyed by a cataclysmic event, but slowly and surely fades from existence due to its own internal processes. The universe hasn't suffered a dramatic end, but has simply run its course and run out of energy, a slow fade into oblivion. What if our universe is just one of many? This intriguing inquiry navigates us towards the enthralling idea of multiple universes, the multiverse. Envision a boundless cosmic terrain, each universe represented as an isolated bubble, peacefully floating in the unimaginable vastness of space-time fabric. This creative visualization provides the basic gist of the multiverse theory. This comprehensive hypothesis puts forth an idea that our universe, which operates under its distinctive set of physical laws and constants, is merely one among countless others. Each of these universes could potentially be governed by a different set of physical laws, or even possess different dimensions, presenting a diverse set of physical realities. Therefore, it implies that the destiny of our universe may not necessarily be duplicated. In others, some might undergo a collapse, while others might perpetually expand. There could also be universes trapped in an eternal loop of creation and annihilation, repeating the processes in a never-ending cycle. Parallel universes are another fascinating aspect that could exist, perfectly mirroring our universe in some aspects, while drastically diverging in others. These possibilities are mind-boggling and challenge our fundamental understanding of existence, reality, and our significance amidst the vast cosmos. It makes us question if we are the sole inhabitants of this cosmic spectacle, or if we are just a tiny fraction of a more complex, grand design. Such a concept initiates a profound introspection about our unique place within the intricate cosmic framework. Ultimately, we are left to contemplate, are we truly alone, or just a single patch in a cosmic patchwork quilt filled with infinite possibilities? Could quantum mechanics hold the key to the universe's fate? We venture into the quantum domain, an enigma that challenges our conventional wisdom, a realm of uncertainties and probabilities. Quantum mechanics, a field of physics that describes the behavior of particles at the smallest scales, presents theories such as the many worlds interpretation. This theory suggests that for every event, every conceivable result happens, each within its own distinct universe. Now let's visualize a cosmos in which quantum fluctuations, brief variations in energy that arise even in seemingly vacant space, trigger a new Big Bang, commencing a new sequence of cosmic evolution. These fluctuations are not random anomalies, but a core part of the quantum world. Several theories propose that these quantum fluctuations could be pivotal in determining the fate of our universe. So, envision this scenario, a universe that perishes, only to be revitalized again and again in an eternal cycle of death and rebirth. All of this could be possible due to the intriguing and puzzling world of quantum mechanics. However, it's essential to remember, these are just theories, yet to be solidified by empirical evidence. Who knows, the actuality of our universe might be even more bewildering than what our current quantum theories suggest. The exploration of the quantum realm is like stepping into an abyss of unknowns, a journey that continually challenges our understanding of reality and pushes the boundaries of our knowledge. It's a thrilling yet terrifying leap into the enigma that is our universe, a quantum leap into the unknown. What if the universe is in an endless loop of expansion and contraction? This question fuels the conceptual framework of the Cyclic Model. This model suggests that our universe is a timeless entity, cycling through periods of expansion and contraction over and over again. It's not unlike the rhythmic pattern of breathing, but on an unimaginably vast cosmic scale. This theoretical model has ties to the Big Bounce theory, another fascinating concept in cosmological studies. Remember our earlier discussions about the universe shrinking a tiny point, a singularity, and then exploding outwards in a violent rebirth, a new Big Bang? The cyclic model takes this idea further, positing that this is not a singular event, but a process that cycles endlessly. Under this model, our universe is a mere chapter in an eternal cosmic story, each universe born from the remnants of its predecessor. This suggests an intricate ballet of cosmic events, the universe expanding, then contracting, before expanding once more, a never-ending dance that has been playing out since time immemorial. The idea is mind-boggling, isn't it? Instead of viewing the universe as a one-off event, the cyclic model invites us to see it as an ongoing, rhythmic process, a grand cosmic spectacle that doesn't adhere to our linear understanding of time, but instead transcends it, repeating its cycle in a timeless cosmic waltz. It's not just a theory, it's a radical reimagining of the universe's very nature. Doesn't it make you look at the stars differently? A cosmic dance, forever repeating. So, what does the future hold for our universe? We've traversed the Big Freeze's vast, cold emptiness, witnessed the Big Crunch's dramatic recoil, felt the Big Rip's destructive might, and envisioned the Big Bounce's hopeful resurgence. We've contemplated the abrupt finale in vacuum decay and the eternal possibilities of the multiverse. We've probed quantum theory's convoluted implications and the universe's cyclical pattern, suggested by the cyclic model. These theories, as distinct in nature and cosmic as the universe they interpret, highlight the significance of consistent scientific exploration. They emphasize that our comprehension of the universe is always progressing, influenced by novel findings and unique viewpoints. The universe's colossal enigma is spun with strands of dark matter and energy, and the luminous glow of infinite stars. Its future is unpredictable, its conclusion undisclosed. In the end, the universe keeps its secrets well, but isn't the journey of discovery thrilling?